Hope I don't cut my hair by accident. How much force does it take me to cut my hair? Or to cut off my nose? Don't try this at home. Yeah, no, I'm not even going to try it here. Ah! How much force would it take? How much force is it taking me to lift this big shell up over my head? Awesome shell, huh? Isn't that cool? So awesome. But it's really heavy and it takes a certain amount of strength to hold it up. If I let go, it will fall. If I don't let go, I'm really acting against the force of gravity and it's not moving. We're going to look at forces today. Hey, here's a force for you. How much force is it taking me to crank this music box? What is a force, Mrs. Tomlinson? Can you clarify that for us? Why, yes, students, I can. Here we go. Today, our learning target is I can determine the net force on a balanced or unbalanced object. So, let's talk about force. Force is our key term there. Say it with me. Force. May the force be with you, of course. Force is a push or pull with the size and direction. So, like, how much force and which direction does something move? Net force, say it with me, net force is the force that results from combining all the forces on an object. So, like if I'm lifting my pen, I'm not only lifting my pen to hold it up, but gravity is pulling it down at the same time. Okay? And if I'm moving it to the right, I'm lifting it up, gravity is pulling it down, and it's moving one way or the other. All right. Newton. This is symbolized with an N. Newton. Say it with me. Newton. N. It's the unit used to express force. So if force is 5, it's 5 newtons of force. All right, we're going to talk about what is a balanced force. It really means that there's no movement. It has a net force of 0. And you're going to put an example here. We're going to talk about what an unbalanced force is, which really is when something moves, it's unbalanced. That has a net force of greater than, look at that symbol, you thought you'd never use it anywhere except for math and emojis. Greater or less than 0. And you're going to put an example of an unbalanced force here. If you get stuck, go look at your learning targets. We are on notebook page 58. Please fill in these blanks on this page. When forces are in different directions, you do what to find the direction of net force? And when forces are in the same direction, you do what to find the direction of the net force? You're going to use add or subtract to complete the sentences right here. Not real complicated. You could probably guess it right off the bat. Page 59, another learning target. You knew we were doing 2 today. So you're going to learn some cool information, and I would like you to remember to use a ruler. Okay, I did that in slow motion. Did you notice? It wasn't a video trick. It was just your crazy teacher. All right, I understand a force can be shown with a vector. So you can actually show what happens with force and movement and motion by drawing a vector. Doesn't that sound cool? Vector, like it kind of actually sounds like a villain from a movie you might know. Vector. Anyway, but this vector is a line with an arrow that begins with a dot. I know, Mrs. Tomlinson, not very complicated. A line with an arrow that begins with a dot. Except for everything has a meaning. So the dot shows where the force begins, the length of the arrow shows the amount of force, and the arrow actually shows the direction of the force. So here is a vector. It was really complicated to draw this in my notebook, so I used a ruler like you're going to. And I want to make sure that we use the actual lines of our notebook to count. So like 1, 2, okay, so 1, 2, 3. That's 3 newtons, and the direction is up. Okay? You're going to draw number 2, you're going to draw number 3, number 4, and number 5. Number 2 goes to the right. That's the direction of the force. You just have to count how many newtons it is. I bet you can get the rest of them. Be really careful, again, use a ruler. Let's talk about some of these concepts really carefully together, and then I will let you get started. Here's something we quickly covered was that there is something called a balanced force and something called an unbalanced force, okay? So if it's balanced, there's actually no movement. So if there's a force from the left of 3 newtons and a force from the right of 3 newtons, if they're headed towards each other, they kind of cancel each other out. And so the net force becomes 0 because they cancel each other out. If the net force is 0, then you have a balanced force, which means no movement, okay? If you have an unbalanced force, like the strongest force here is coming from the left and the weakest is coming from the right, well, the strongest force, if it was pushing that direction, 10 newtons, and the weakest force, if it's pushing this direction, 3 newtons, the strongest force is going to kind of win, right? And it's going to win with a net force of 7. And it's going to end up going to the right because that's a stronger force. If it's an unbalanced force, that means it's greater or less than 0, then you have an unbalanced force, okay? And it means that there is movement that happens, and you use an arrow, which is a vector, to show which direction it goes. Okay, so let's look at this particular object. And you guys are welcome to use your calculators if you want. Let's look at this particular object. Let's look at the forces. So we have 50 newtons of force going to the right, another 15 newtons of force going to the right. This is the object, right? And then you have 100 newtons going to the left. Well, 50 plus 50 is 100. This is where your math comes in. 100 newtons pushing to the right and 100 newtons pushing to the left. Your net force is 0, right? Because it's a balanced force. It's balanced. It's not going to go either direction. Same amount of force, both directions, okay? So it's going to stay right here. There's no force, actually, that's unbalanced here. All right, let's look at some more net force. It says, which cube will move with a net force of 30 newtons to the right? So we're going to look at one that has stronger to the right. So we have cube A, cube B, cube C, cube D. We have 15 to the right, 15 newtons to the left. Well, if they're opposite forces, they just cancel each other out. We know that our net force here is 0. I put a line through it so you can tell it's not an O. Oops, sorry, let me move that over. If we have 50 newtons to the left and 15 newtons to the right, they're pulling like at an equal force, right? And so, again, we have a balanced force. There's no motion going on here. All right, let's look at C. We have 15 newtons to the right and another 15 newtons to the right, since they're both moving the same direction. We have 30 newtons. You just add them together if they move the same direction. So we can say 30 newtons to the right. Or if you want to write it, you can write 30 newtons to the right. Okay, this one has 15 newtons to the left, 15 newtons to the left. Because they're both going the same direction, you add them together, you get 30 newtons, and our direction is left, okay? Or you can write 30 N with left, and that works. Remember, N stands for newtons. Get your units right. All right, let's see if you can get this one. I'll pause it. You give it a shot. I want to know what the net force is and what direction it's going to go. Okay, if you saw that you have 5 newtons to the left and 9 newtons to the left, you have to add them together, right? So 9 plus 5 is 14 because they're going the same direction. So you have 14 newtons and your direction is to the left. Did you get it? All right, let's try another one. I love this little cartoon dude. He reminds me of me. That's what I look like in my car when I put on the brakes. All right, let's do this. I want to know, what's the net force? What direction is it going? And is it balanced or unbalanced? Okay, we have 7 newtons to the left. We have 10 newtons to the right. Stronger going to the right, so we definitely are going to have some motion to the right. How much stronger? It's 3 newtons stronger, right? 10 take away 7 is 3 to the right. And because there is movement, this is unbalanced. Okay, what could we make this number right here if we wanted to make this a balanced force. What could we do to this number if we wanted to make it a balanced force? Raise your hand if you think you know. Yep, you could add 3 newtons to the left. That way you would have 10 over here and 10 over here. Would balance each other out, and then you have no motion. All right, last one. I'm going to ask you, is this balanced or unbalanced? Raise your hand if you think you know. Okay, since we have 450 newtons to the right and 450 newtons to the right, what do we have to do to figure out this net force? We have to add them together. So when the forces are going in the same direction, you add them together. When they're going the opposite direction or working against each other, you subtract. You never have a negative force. So 450 plus 450 is, I don't even know what that is, like 900 newtons, and our direction is to the right. Okay, let's have some fun with this, get some good examples, and there's a really quick video that you're going to watch, and then you're going to do a couple notebook pages, and then you're going to submit a Google form to me today to show me what you know. You got this. Have a great day.